Yeah, it looks like it's working. Great. Cool. So yeah, data types. This is the outline for this week, and I want to just like spend a second on it because, oh wait, did I click record? Just making sure. Yes, cool. So I want to pause on this for a second because there's like a reason for them being in this order, which is basically we're going to start by talking about like what exactly is a data type, like what do you even mean by that, and then we will talk about there are 4 like basic, like they're called primitive types in Python, meaning like in any programming language there's primitive types and then non-primitive types, and Python has 4 of them that we'll talk about first, and then if we get to it, if we have time, we'll talk about sort of the non-primitive types, which are like fancier types of data types. So, but importantly, number 1, right? Like what's a data type? Like why do we have a whole lesson on this? Last week we basically just learned that like Python, right? As a recap, Python is a program that runs on your computer or on a server, NYU server, and then Jupyter is a program that runs on top of it, right? And like sends commands, sends Python code to the Python program, gets the output and like displays it, right? So the data, like I just kind of started typing stuff to show you that. But data types are like the actual, representations of objects that we'd want to use, right, when we're programming. So like when you print something or when you do math, right, when you print something, you're printing a thing that lives in the memory of the computer that at the end of the day, at the bottom of the like stack of complexity is just zeros and ones, right? So actually, like, even though it's 5th on this list for reasons that you'll see, there's a type called a Boolean type, right? And that's actually like the least complex type of thing that you can have in Python because it's just 0, 1, right? It's just like true, false. And like, if you look up computers from like the 1940s, you'll see they're just these gigantic like warehouse sized things that just have switches right between 0 and 1. And like you can imagine, you fast forward like 100 years and suddenly now we have like our phones, but the logic of computers, right, it's still based on these 0, 1. So I just wanted to point out that bool is like the most basic type, but it's not the type we'll use the most, right? So this is kind of in order of like what we'll use the most in this class and in data science in general, right? So integers, they're just sequences of bytes under the hood, right? 5, -7, things like that. Right, so you can imagine you take the 0 and 1, right? You take the bit, I should have said that's called like a bit, a 0 or 1. It's a bit, and then you take those and you like string a bunch of them together and suddenly you can represent integers, right? And we'll talk about it, but computers are finite, right? Like the memory has to be these finite discrete chunks of 0, 1, 0, 1 binary stuff. And so actually, like, even though to us as humans, integers are anything like, could be towards -infinity, it could be towards infinity, just like whole non-decimal numbers, right? But to Python, we'll see, but there actually is a biggest and smallest one. So you have to be careful about that, because then when we move to floats, right, floats are decimal point numbers, like real numbers is what we call them in like math. And if you think about it, right, even though there's already limitations on how Python can store integers, right? Because there's a maximum value and a minimum value. At least like it can what's the word? Reliably store all the possible integers that it can store. And why I phrase it like that is when we get to floats, right? So like from high school math and stuff, hopefully, you know, like between 1 and 2. If I knew how to set up like polls in Zoom, I would set it up. But like between 1 and 2, like how many real numbers are there between the integer 1 and the integer 2, right? And like the answer is like infinity, right? Because there's like 1.5, 1.25, 1.125, and so on and so on. You can always cut it. So the point being, like, there's already restrictions on integers, and I just want to like drive the point home for any headaches later on that you can imagine then there's like even more like restrictions and sort of shortcomings of the way that Python has to store floats, right? Decimal numbers. And long story short, if you like, we'll get into it, but the heuristic to help you is the rule of thumb is like, you can imagine Python at a certain point just has to like cut off the decimal. So two numbers that you might think are equal, Python might not like think are equal, or sorry, the other way around. Two numbers that you don't think are equal, right? Because they have different like decimal representations. Python will think they're equal because it's just like chopping off the decimals, right? Because finite memory. So, you know, each week I kind of say the thing that's like, if you remember one thing from this section, that's my one for this week. It's that sort of, even though these are primitive types, just remember that, yeah, computers are either limited, though precise when they work with like ints, but they're actually both limited and actually like imprecise when they work with floats. It's very like weird. Like you think computers are these perfect math machines, but actually, you know, you can Google like Mantissa. That's the name of the system for how Python stores floats, and it's not. It's like you're always like approximating because you can't store every float. And if anyone's a math major, it's like Cantor diagonalization. Is fun. My favorite math proof that you cannot like make a list of all the real numbers, right? You can make a list of all the integers, and weirdly, all of the well, I won't get into it. Anyway, you can make a list of all the integers, but not floats, and that actually comes into play in Python. Cool. And then string is kind of like this convenience thing that Python gives us in a way, because like strings are just collections of characters or emojis or like whatever linguistic units you want to think of, right? It can be like, I don't know, here like Hangul, like characters, like any character. A string is like a sequence of them. So like your name, right, written in whatever language, it's a sequence of characters, and that's a string, right? I'm being so general about it because I don't want you to just think it has to be like English language words, right? That'll come into play. You'll see. It can get hairy. But the point is, like, those are stored as numbers, really, like under the hood internally in Python. But Python kind of almost provides this like convenience interface to strings, right? So that instead of typing like, instead of having to remember like, okay, the number for like Q or Z or X is 33, 50. You don't have to like memorize the numbers codes for characters, right? They're just, Python handles all that with the string class, right? Like every character in every language, because of Unicode, corresponds to some number, but it could be like 10 million. So you can't memorize them. Python has a string type that lets you work with characters, text, right? Without worrying about like 0, 1 representations. Cool. And then there's kind of, imagine like a dividing line after 5, right? I talked about bools, but because after 5, it's the non-primitive things where like functions are first sort of this metadata type, where actually they're blocks of code, right? They're just blocks of Python code. So like you can imagine taking like the code from a Jupyter cell and like storing that in a variable, right? It's kind of weird to think about, but you store like the whole sequence, right? You store like an algorithm, you store code in a variable. That's a function. We'll get to that. And then lists hopefully are a little bit easier to like wrap your head around because they're just sequences. They're just collections of these other data types, right? So like you can have a list that's like the first thing in it is the number 3, the second thing in it is pi, and the third thing in it is like your name. Python doesn't actually care that they're the same type. It just lets you toss things into it. So just imagine like a big like box of of any variable. And because last week I ranted for some reason about the stack versus the heap, if it helps, like, yeah, the primitive data types, I think I mentioned this, but the primitive data types are the ones stored on the stack. But once you get to like functions, lists, NumPy types, anything more complicated, it's stored on the heap. And that may come in handy in like a month with debugging. Cool. So let's get started. Integers, right? They're what they sound like, quote unquote whole numbers. But you'll see the first thing you'll notice is that, like, if you're a math person, right, you'll know like infinity, negative infinity, those aren't actually like integers in the mathematical sense, right? They're actually kind of just like concepts. But in Python, they kind of provide negative infinity and infinity as these like convenience ints, right? Integers, just basically so that you can have a way of representing infinity. And all that means is that infinity, quote unquote, is like a Python number that just, all that it does is it says like, oh, I'm bigger than that number, right? Like when you compare any number with it, it's like, oh, I'm bigger than it, right? So it's kind of just this weird Python setup. And that's like, because to handle that, you will eventually hit the limit of the lowest number and the lowest integer and the highest integer you can represent in Python, right? Like you could go look it up. Like there is a number, it's like 1 billion. And anything past that, you have to just use like this weird, you know, Python infinity construct. But it works just like any other number, right? Like -7. So let's, coming back down to normal C. Here we have like an assignment statement like we've seen last week, where we take -7, right, a perfectly fine integer, and we store it in the variable called foo, right? We store it in the box in memory that is called foo. If you remember my like boxes in memory metaphor from last week, yeah, it's in the stack. It's called foo, and we say put -7 in there. Cool. And then when we print it, it displays it. And remember also that in Jupyter, if you just like put a variable and you run the cell, put the name of a variable and run the cell, like it will output it. But I want you to kind of not get in the habit of that so much, even though I am, only because like, yeah, it's not good practice because you want to be very explicit, right? You want to use the print statement to like show your future self or other people that are looking at your code, like what exactly is this thing being printed out? So anyway, yeah, we put the integer in the print function and it displays it. So far, so good. Floats. Yeah. Like I said, they're kind of like real numbers, right? You can think of them as decimal numbers. Don't worry about, I'm very happy to talk about like the math, but don't, for the sake of like just learning what you need to know for data science, don't worry about rational real stuff. Just know that like it's decimal numbers like 5.5. And we store it just like that. We can print it out. Great. So far, so good. It's just 2 different types of variables, right? Integers, no decimals. Floats have decimal, or numbers with decimals. But But now I want you to always kind of do this exercise when you learn a new data type in any language, which is like where things can get tricky, right, is how you combine different variables, right, different types, when you combine these data types, right? So for example, the first, right, we only know 2 data types so far, right, int and float, but already you can imagine like, how do they like work together? So like if you're just working with ints, the math works like you expect, like we talked about last week. You can add them, multiply them, whatever. If you're just working with floats, again, it's like internally consistent in a way. We'll talk about it, but you can just work with the floats, you can add them, multiply them, and everything works as expected. But now I want you to start thinking about like what happens if you combine them, right? What happens if you take an int value and a float value and you add them, right? So in this case, yeah, here I'll go back and show you. But bar alt is an int, right? Because there's no decimal. We just set it to be 5. Whereas bar is a float because it has a decimal. And when we add them, what do we get, right? We get this decimal number. And I'm going to open my Jupyter Lab real quick because I want to show you, like, I want you to get in the habit of just constantly using the type function, right? There's a built-in function in Python called type, like type. And last week we learned print, right? Well, type is our like main function we're going to talk about this week, where, give it a second to load, but type, you give it a variable and it tells you what type it is. It sounds like, oh, I don't know, I can just keep track in my head, but like, trust me, it gets hairy. And the type function is very much your friend. Cool. So let me just make some new lines here. And so, right, we can make our first variable, my int equals 5, and my float equals 5.5. And the type function, right, just in the same way that print displays things, type displays what Python data type things are, right? So when you do type my int, it says int, right? When you say type my float, it says float. And so you can use this, right? Like not even theoretically, like in practice, like you should use this function to constantly make sure you know the types of all the variables that you're using, but also like the ways that they combine, right? So because if we say we add my int plus my float, and we store it in like, let's call it combo, right? First we can print it, right? We can look at its value, and it looks like it's probably a float, but that can be very deceiving. We'll see in a few slides why that can be deceiving if you just print it out and like guess, right? You really, like, at the end of the day, you want to do the print type. You want to do both of those. Like, every single day when I code, like, if you look at my code, like I constantly am doing print, but then also type, right? Because I want to see like what the result of my operation was. But I also want to see what the data type is, because, you know, if it's not what I expected, like something went wrong with my program, you know, with my code. So the type, very much your friend. And you'll see here, Python does the smart thing in the sense that it says, okay, if you have a float and you add an int to it, the result, it still has to be a float, right? Because, I mean, it doesn't have to be, but that will allow it to represent more things, represent more numbers, right? So because when you add an int and a float, there's a chance that the result will be a float. Most likely it will be a float. Python just says yes. When you do, you know, addition between a variable of type int and a variable of type float, I will produce a variable of type float, right? So that's like our first exercise in using the Jupyter notebook to test that, to see how these data types combine. Cool. Yeah, floats and integers play nice together. The last thing I want to say on that, for anyone interested, is like there's a lot of really widely used languages where this is not true, and it's really the cause of like a ton of errors. For example, like JavaScript, like hopefully you've heard of JavaScript. JavaScript is like data type combination nightmare. It really it does not do what you expect. Ask me about that outside of section if you're interested, but it is the most popular web development language, and yet trust me, it does not, things don't work together as intuitively as this, right? But Python is very good at that. So it's a nice language if you haven't programmed before, to use your intuition from high school math about all right, yeah, when I add or multiply two floats, I get a float back, right? If you want to get fancy, you can think about oh, from math, if I multiply complex numbers, what do I get, right? And then see how Python does it. Cool. Strings, right? That's what I was talking about before, where it's just a sequence of characters. And Python, right, at the end of the day, it is storing it as a number. To Python, this right here is actually that's just some number, right? But as humans, we think of these as their own type of thing. So it's just a different, I don't know if this hurts your brain or helps your brain, but it's just a different type of representation of a number, right? The number 327, you can be oh, how do I represent that? 327? Or you can be oh, I can make a little table saying 1 will be A, 2 will be B, 3 will be C. You can do that, and that's all that's happening, right? String is just a interface that Python's providing, so that you don't ever have to worry about numbers for strings. It's just you want to work with numbers, use int and float. You want to work with strings, use string, right? So, and you can print them. I should say the quotes are can be really confusing at first, which is Python lets you use either a single quote or a double quote to denote that you are trying to make a string. You just have to be consistent about, meaning if you start it with a single quote, you have to end it with a single quote, right? If you start it with a double quote, like here, you have to end it with a double quote. If you try to, if you say my string equals hello DSUA111, but right, but if you accidentally use a different type of quote for the beginning and the end, it's gonna get an error, right? Python's gonna say, oh, you started this with a double quote, and I was looking for the end double quote and never found it, right? So it's not it's one of the many things where you're wow, we can do facial recognition, we can go to the moon with computers, but it can't figure this out, right? It can, but it doesn't. So yeah, as long as you are consistent with double quotes or single quotes, you're fine. And meaning you can switch between them, right? You can use the double quotes, you can use the single quotes. Yeah, people who arguing about programming will just be yeah, use single quotes because you don't have to hold down shift. But in other languages, you have to be super careful, because in other languages, the single quote and the double quote actually means different things. Sorry to say, but if you're just saying in Python, or you imagine in your life you're only ever going to use Python, yeah, you don't have to worry about the quote stuff. Cool. But yeah, by the way, if there's questions, just tell me in the chat, or just say something, right? But cool, because now we're going to talk about like, if now is the time when we hit some of the when we start to hit some of the nightmares in terms of combining these data types, like I mentioned, right? Which is like, okay, well, the problem with like a string is that Python doesn't know what is like inside of it. So as far as Python's concerned, that string is no different from some number, and it has like a big table, right? Of like, you know, the Latin character A is this number. Hopefully you get that by now, but the point being, like, look, we can make a string that's like the minus sign and then 7, right? And to us as humans, like that looks like a number. We're like, that's a number, we can do math with it, right? Not to Python, right? To Python, it's not a number at all, and like it won't let you do math with it. And I'm not joking, like this is gonna be the number, at least in the top 3 like errors that are gonna happen and headaches that are gonna happen, like in data science for you, is just, yeah, you'll call like some fancy, you know, statistical function, algorithm, and it will like give you a result, but the result will be like a string instead of a int, but you'll think it's an int or something, and you'll start doing math with it. And yeah, it's a real like rabbit hole. It's a real black hole of headaches, right? Because minus sign 7, different from the integer -7. 5 and then a dot and then 0, right? Surrounded by quotes. Completely different in Python's like mind than a float, right? And so like we print these things out and we think, here, let me show you, because like if you print, say you make you know, x equals -7, just like before. But if you print x, you'll just see -7, right? And what you just saw just there is like the bane of my existence, because if you like say, I don't know, you scroll past that and you're just looking at someone's code, right? And you see like print x and you see -7, you're like, all right, great, it's an int, right? So then you start, you know, you're like, all right, I'll take it from here, and you start working with it like an int, right? Hopefully, does that? I hope that makes like sense of why that can cause some huge nightmares. And that's why you should always use like type. Like type is there as like an escape rope, right? That's like a way outdated Pokemon reference, I'm sorry, but yeah, just if you're in the cave and it's like all dark, you use the escape rope to get out, right? If you're working with all these variables and they start to combine in weird ways, you use type to like figure out what's going on, right? And you see, oh, okay, it looked like a int, right, when I printed it out, but it's actually a type string. Cool. So just like, please do that as much as possible, basically, because when you start Python, it's called overloading. Like Python will overload the addition symbol and the multiplication symbol and all the symbols you know from math, but they have different meanings when you're working with strings, right? So the plus sign, I want you to, there's like an annoyingly long word, but it's really helpful to know, which is that in Python, when you do the plus sign with strings, it's called concatenation, right? And it just means like taking the first thing. Well, it means taking the second thing and just tacking it on, right? Appending it to the end of the first thing. So in this case, you know, we have this string -7, and then the string 5.0. And when we use the plus sign, it does not do the math, right? It does the concatenation of the strings. So it just takes 5.0 and it puts it at the end of the -7, right? And yeah, like us as humans, we see that and we're like, oh, it's another number, right? -75. Cool. I just did math, right? But it's like not a mathematical. No math is happening here, really, right? You're just stapling one string onto the end of another one. Cool. So yeah, hopefully this like really drives the point home about headaches and using type. before, right? You want to use type before you get to this point so that you know, like, all right, if I'm like you want to know what the plus sign that you're writing in your code is like doing, right? Is it doing mathematical addition or is it doing concatenation of strings? And like, in fact, it gets even weirder because, like I said, it not only overloads the plus sign for strings, but it also overloads the multiplication symbol. It might overload a bunch more. Like there's just all this weird stuff. This is why you use the Jupyter notebooks and you just test it, right? But it overloads the multiplication with, if you have a string, but then it's multiplied by an int, that means like repeat this many times, right? So like plus sign concatenation, multiplication sign repetition, right? So before we had negative, I have to like specifically say like minus sign 7 so that I'm not saying -7 the number, I'm saying minus sign 7 the string. That multiplied by 5 just is minus sign 7 minus sign 7 minus sign 5 times, right? But if you think about it, right, so that works because with like semantics of language, you can imagine like I ask you like, hey, repeat this 5 times, right? Repeat this 7 times, repeat this 14 times. Meaning like it works if it's a positive int, right? If it's a positive integer. It completely stops working if I say like, hey, go ahead and repeat that 5.37628 times, right? It's just not like a well-defined thing. It's not not a well-defined operation. And so finally, like that's where we break Python, right? When we try to multiply a string by a float, right? By a non-int. So I'm just going to make it even more clear than it is on the slides there, because it's like, if you have hello, right? You multiply by 5, you get 5. You get hello, hello, hello 5 times, concatenated to itself 5 times. But if you try to do like hello times 5.37382, it's just like I don't know what you're talking about anymore, So yeah, and I include that and bring that up because I want to. It's very helpful. Like it's very helpful, the error message. You don't want to just see the error message and be like, oh no, I messed up, I give up. You want to see the error message and like interpret it, right? See what it's trying to say. And in this case, it says can't multiply sequence by non-int of type float, right? So let's like parse what that means. It just means that like if you think about it, if you infer from this, it's saying, okay, so I can multiply sequences by ints, right? A sequence is just Python's word, like Python's name for any data type that's like a collection of primitive data types, right? In this case, a string, it's very weird. I'm sorry, it's like I guess you're just gonna have to memorize like some of these things, but like a string is technically treated by Python as a sequence of like single characters, right? Because full, if you like notice what I was saying before about the number codes, like full strings like Jeff, Jacobs, or like hello, like these are not, there's no number for that full string, right? There's numbers for each individual character that Python knows, right? And so when you type a string, it's a sequence, right? It's a collection of those characters where each character has its own number code, right? And so what it's saying here is like I can't multiply a sequence by a non-int, right? And so the sequence in this case is the string. So in this case, I just want you to read that. When you see sequence, don't like be scared because it's kind of a new word or like a weird word. It just means the string in this case, right? It has to use the word sequence because you can also make sequences, right? You can make collections of not letters, right? We saw that, I talked about that at the beginning with list, right? List is a type where it's not restricted to like letter, the first letter, the second letter, the third letter, right? It's can be anything. So that's why it uses the word sequence, right? But that's what that error message means. In this case, it's saying, hey, you gave me the sequence, right? A string, a sequence of characters, and I don't know how to multiply it by anything other than an int. Cool. So yeah, playing nice. That's like the first time we've kind of broken. We'll break Python a lot and see why, but that's the first time we broke it on like combining objects in weird ways, right? Combining these data types in weird ways. So yeah, how do you repeat hello 3.76 times is what I was talking about. There's a second thing though, similar, but like just another example, which is when you try to add strings with other things, right? Meaning when you try to use the multiplication sign, because we talked about multiplication sign for just numbers, right? 2 numbers, cool. We're comfortable in that zone. It's normal mathematical addition, right? And then if we're just using strings, we're also fine. We're using the plus sign because we know it's concatenation, right? But when we start combining, like we're trying to do plus, right? We're trying to use the plus sign with 2 different types of objects. Yeah, we have to really be careful, right? Because int and string, in this case, like we're trying to add -7, not the string -7, but the actual int -7, but then the string 5 and then a dot and then 0. And the point here, what Python's saying with this error is that it's just like, it's not, there's an ambiguity, like, and it's not, and it does not know how to resolve that, right? Let me show you what I mean by that, which is like, sorry, what's this? All right, hopefully, is this big enough? I'll make it a little bigger. Cool, so like if we have an int, my int is 5, then we have my string, and it's like hello. Now, if we try to do my int plus my string, right, we get that error that was on the slides. But let's just like think through it a little bit more, right? Because maybe we're talking about the relationship between intuition and like what Python does. So maybe our intuition would be like, oh wait, why doesn't that work? Like I want it to produce, you know, this 5 hello or something, right? There's a reason Python doesn't like just produce that, just say like, oh, okay, it's whatever. Yeah, I'll convert the int into a string and concatenate them. And the reason is the thing that I mentioned, where the strings themselves can store representations of numbers, right? Meaning like, so 5 hello. So yeah, but like imagine if you had a different case, which was, let me think of a good one. Oh, right, okay. Yeah, well, what if you had like this, right? That's the case, right? Between like this case up here and this case up here, that's the ambiguity, right? Which is that like, it doesn't know whether you want it to just convert the number into a string and concatenate them, right? Producing this, or maybe convert the string into a number and do math, right? Does it make sense? Like it doesn't know what conversion it's supposed to do, right? And so in the earlier section, someone had a really good question, right? Which is like, well, okay, that's good to know, but like, what do I actually do in this situation? Like I know what I want to do, right? Like I know I want it to convert this into a string or something, right? The answer is we use conversion functions, right? Python has, for every data type that we're going to learn, Python has a built-in conversion function, which means like it's a function that tells Python like, I want you to treat this like an int, or I want you to treat this like a string, float, whatever. And it's a bit confusing, but the way that you use these converter functions is you just write the name of the data type, but then put parentheses, right? And then you put the thing you want it to convert to an int. So in this case, let me say like result. And then let me see what type result is, right? So what happened here is like the full sequence would be like this. Cool. There. So first we just have like the string containing the digit 8, right? We print it, can't tell from that what its type is, right? But we could do like that, right? We can see, okay, great, that's a string. This is the converter function. This is the line I want you to focus on, because it this int, right? Suddenly int is a function. It's a built-in Python function, and it just takes whatever arguments you give it, and it just does its best to like convert it, right? In this case, like 8 is easy. It works, right? And your result, the result of that function call is 8, but now if you look at the type, it's an int, right? It's no longer a string. But you know, if you did like int what's up, it wouldn't know how to convert that, right? Like it doesn't know how to treat that as a number. And that's how you can get out of these nightmares of like, oh no, am I combining strings and numbers, right? You open a Jupyter notebook, you use the type function, you use these converter functions, and you look at the errors, right? Like it's fun. That's what I meant last week when I was like, the errors are actually there to help you. Sorry, 1 second, there's a noise. Sorry about that. So great, right? We're just, the Jupyter notebooks are literally just there for you to experiment and try these things out, right? In this case, invalid literal for int with base 10. What's up? All that means is it's saying like, I don't know how to convert this into a base 10 number. You don't have to worry about the base 10 thing, but there's a second, like, here, I'll show you. Why not? If we do int like that, it thinks, okay, that's the number 100, right? Like the way we use like base 10 in our communication, whatever. And it's like, that's 100, but you could also tell it, oh, do base 2, right? And suddenly that becomes a binary number. And that means like, this is the 1s column, this is the 2s column, and this is the 4s column, right? And so 4s column is 1, and the other columns are 0, so it's 4, right? It like converts it back to base 10 when you display it, right? But anyway, the point is just like, it's gonna do its best to convert the string or anything that you give it into an int, right? And so that's the fix to like all this nightmare stuff up here of like, you know, how would I resolve this? Like, I called my fancy my fancy statistical function A, and it gave me number 5. I called my fancy statistical function B, but they gave me a string for some reason instead of an int. Like, what do? I say, oh, I want to do math with these, right? I want to add these. Like, I want the plus sign to be addition. The way you tell Python that is you just say like, make sure they're ints, right? You use these conversion functions like that, and then make sure it does math. Whereas if you wanted to do, you're like, no, actually I want you to treat them as strings, and I want the plus sign to be concatenation. You just do the same thing, right? But you use str and it knows, okay, I'm gonna convert that to a string. I'm gonna make sure that's a string, right? It's already a string, so I don't have to do any conversion, and then concatenate them, right? So maybe this can be like your Rosetta Stone for understanding how to like force Python to do certain operations. Cool. yeah, you can look through all this. It's just you hopefully get the picture that there's all these nightmares about combining different data types, and you just want to use type to check what's going on. And then you want to use these converter functions that I mentioned, right? Int, str, float. Every data type has its own converter function to be like, to force Python to do what you want it to do, right? Okay. I just want to draw that home because for the sake of time, like I'm going to speed a little bit, and I just want to get to functions, and then we'll talk about functions fully next week. Booleans, I talked about them at the beginning. Yeah, true or false. The only weird thing to know about those is like, you know, in the same way that you can type 5 to tell Python, and like Python will interpret that as the int 5, right? Do that, right? It's int. There are exactly 2 things that you can type to create Booleans, right? One is true with a capital T, and the other is false with a capital F, right? Using print to make sure everything gets printed. And if you look at the types, right, it's bool. So it's not like, we don't usually use Booleans explicitly like this that much. Usually it's just the result of a thing, of a operation, right? Like we talked last week about the annoying difference between the single equals, which is variable assignment, and the double equals, which is like asking a question, like, are these equal, right? Well, if you notice, right, like if I do 5 times 2 is 10, and it's like true, right, under the hood, it has just created Python has created a Boolean, right? So meaning when you ask it a logical question like this, it produces a Boolean value. We could even do like result equals. I like doing it like this so I can see like the result equals like, what's the answer to this question, right? And result is true, and it has type. Cool, cool. So that's where Booleans come in. They're like the answers to questions. And yeah, they have their own conversion. And one, like the headache with this is, yes, again, just in the same way that Python lets you put numbers into strings and it causes nightmares, it also, right, it's perfectly fine with you typing the word true with a capital T or the word false with a capital F in as a string, right? But it doesn't know that that's like, if you want to use that as a Boolean value, right? It thinks you want to use it as a string, you know, so you can say like, my var equals true. Other var equals, you know, false. Yeah, and just it thinks these are strings. It doesn't interpret them as bools. But again, we can use our bool conversion function to make sure, right? Cool. I just want to like, it's the same case as what we've been doing this whole time, where you just have to make sure you know whether a variable someone gives you is a string representation of something or the thing itself, right? Like, is it the actual number 7? Like, is it the actual int, or is it just a string with the digit 7 in it, right? Just like, please remember it, because it's not probably #1 top 3 source of error, like ever. Cool, cool. Yeah, last thing, and then the next slide is functions, so we're good. We can long story short, there's this special word that Python gives us called in, which is the operate, like we've been learning all these operations, right, and how they work with the different data types. Like we've learned that the plus sign has a different meaning with 2 numbers as with 2 strings. In is kind of, you can write, it's just an operation like plus or divide, any other like mathematical operation or logical operation, but in is like the subset operator, right? So meaning Yeah, I never know like what math people learn in high school because people are from like all over the world. But it's, there's like a subset symbol, meaning like, yeah, we'll just do this case where you have my full name, right, Jeffrey. You have like my name, Jeff, and then the in, right, is just saying like, is one a subset of the other, right? And in this case, it's true, right? Because this sequence of characters appears as a subset of this longer sequence of characters, right? But that's just another operation that produces a Boolean. Cool. So yeah, we've been using that type function, blah, blah, blah. We're gonna stop here, but functions are, like, there's a reason I'm not just like splitting everything before this into functions just because of time. They're just like they're a fundamentally different type of object in Python, right? But they're just a block of code. And just last thing, I'll show you like how to create them, right? Which is like def my function. Don't worry about it. We're going to talk about it next week, but def is like you're telling Python you're defining a function, you're giving the name, you tell it the arguments you want it to take. In this case, it doesn't take any arguments. And then in this case, it just prints something. Notice how like I ran this and it didn't print hello though, right? That's because I haven't executed the function yet. Executing the function is when you write the function name, right? And then you give it the arguments if there are any. You execute it, and then it runs the code, right? So it's like a box of code. It's a box of code that just sits there and waits for you to execute it. So that's functions. Yeah, I'm gonna stop there. I'm really sorry for going over time, but I wanted to just show you that. Cool. If there are questions, like definitely let me know in chat or email me. Otherwise, have a great weekend. Thanks. Cool. Great, I'm gonna stop the recording now. So please, I'll be on email tonight. So next week is functions.